Since almost everything in the world is a mixture, we better learn how to purify things. In this screencast, we'll look at purifying fairly simple mixtures, like oil and water, for example. This is screencast 3.3. Okay, imagine various items that we want to purify. Oil and water. Wet sand. Caro syrup, which let's assume is basically water and sugar. Some nice olive oil, which is surprisingly a complex mixture of various soluble liquids. A liquid-liquid solution. Or some mysterious blue liquid where you really don't know what's in it. Let's figure out how we might purify each one of these. Let's say what we want in this particular case is just the oil. In this case, we just want dry sand. Here we'd like to have some nice pure sugar. And here we want them all. We want to separate each of the oils. And in here we just want to figure out what the heck is in there. And to do that we want to separate it into its individual components no matter what they are. Methods of choice for each one. Well, pretty easy to separate oil from water. It's essentially already done for you, isn't it? All you need to do is really decant. You could just simply tip this thing over and pour, or if you wanted to go to more trouble, you can use this device, which is known as a separatory funnel, and let it run that liquid through until you get to that meniscus right there, and you should get a very good separation. To separate wet sand from dry sand, all we got to do is filter out the water. If you have a paper filter right there, that could separate out the sand and the liquid runs through. Great for liquid-solid separations. Let's suppose we want that sugar. Well, you could just evaporate it, but if you really want it pure, you evaporate it very slowly just to the point where it crystallizes. There's more to this. We're making a supersaturated solution and things like that that we'll get to, but boy, is this a nice way to get very, very pure substances. Now, if you want every oil from here, one convenient way to do it is to take advantage of the fact that they all have different boiling points. When that's the case, and as long as they're not too high boiling and not subject to decomposition, you could distill them. So what you've got is some heat applied to your mixture until it boils, and then some surface area here to affect some separation. A thermometer is convenient to see what it's boiling at, and then some way to make it go back to a liquid so it doesn't all just leave as steam. That's called a condenser, and that's a distillation apparatus. If you have some weird mixture and you don't know what it is, perhaps the kingpin of all separations methods is chromatography. You simply take that residue, put it on some solid surface, and elute. That means run some liquid, in this case up through this plate, and have them separation based on adhesion, the adhesion to that solid surface. It can also be done three-dimensionally through a column, pushing it usually down the column. These are various basic separation methods, and this is Screencast 3.3.